Well, welcome to another edition of Big Ideas in App Architecture. Today, I am very excited to have on the show the co-founder and CTO of Cockroach Labs, Peter Mattis. Peter, welcome to the show. Before we get kind of into the thick of architecture and big ideas and all this other stuff, I always find it super interesting to start with kind of your history. How in the world did you come to found and start this very interesting company? So maybe if you can just, start by telling us a little bit about you, a little bit about your background, and then we'll kind of slowly get into the history of Cockroach Labs and all things cockroaches.
All right. Sounds good, Tim. Well, thanks for having me. Glad to be here. My history goes way, way back. I've been in industry going on 25 years now, something like that. So, I got my undergraduate degree at Berkeley. And while at Berkeley, I actually met my co-founder, our co-founder, Spencer Kimball. He was my roommate. He was actually my brother's roommate first, and then he was my roommate. And we quickly, understood that we were like-minded. We loved software and whatnot. Back in my undergraduate degree, I actually got started in graphics. Graphics was my entry drug into computers, kind of gaming, but more on the graphics side. And Spencer and I started this little program that got a bunch of traction afterward called the GIMP. So I did graphics all through my undergrad days, and then I graduated and I was kind of tired of graphics and I moved away from it. And I joined a startup one of my professors had founded called Inktomy. They were an early search engine. They eventually got bought by Yahoo. And earliest days at Inktomy, I was involved in doing network programming, distributed systems programming, not really stuff I'd really done much of in college, but I really liked it. It was a different challenge. From there, bounced around to a couple other startups and then eventually landed at Google. And I was at Google for just shy of a decade and worked on a lot of cool distributed systems problems at Google. I was an early architect of the Gmail search and indexing backend, then worked on distributed file systems, worked on their Google 3 build system, which now is known externally as Bazel. Internally inside Google, it's still known as Blaze. Got deep exposure to a lot of the big distributed systems problems Google was tackling and how they were tackling it. Then eventually decided my time at Google was up and I moved on. And Spencer and I actually did a startup before Cockroach Labs called Viewfinder. It was a mobile photo sharing site. Very, think Instagram, think Snapchat, but we didn't have the secret sauce. We were getting started right at the same time. We could have had success. We didn't have success. We're not consumer guys. We're back-end engineers. It was at Viewfinder that we actually had the original idea for CockroachDB. And what essentially happened is we got outside of Google and we looked around at the ecosystem that was out there and we're like, what can we use for backend storage for these photos and messages in our mobile photo sharing site? And we weren't terribly fond of what we saw. Cassandra was out there, HBase was out there, React was out there. And we're like, well, let's sketch out what the design for how we would do this. And we did. And then we decided, no, that this is a complete tangent from what we're doing at the startup. So we put it on the shelf. And then that startup foundered. We got acqui-hired by Square. And inside Square, we saw the exact same problems, the need for a distributed, horizontally scalable database. And kicked around some ideas at Square and eventually left Square to form Cockroach Labs. And I was just in there from the beginning with Spencer, and then we had our other co-founder, Ben, coming along. But that's in a nutshell.
When did y'all meet Ben in that journey? Was that at Google or was that before?
That was at Google. Okay. So I started at Google in it was April 2002. I think it was April 1st of 2002. I remember that because April Fool's Day. And as soon as I got there, I was like, wow, this place is awesome. And I convinced Spencer, you have to join. And so helped get Spencer, interviewing, helped get him his job. So he was.
What did he want to do? He didn't want to.
He was kind of on the lam right then, just kind of, floating along, not quite sure. He'd had his own startup at the time that had, gone under. And he wasn't quite sure what he wanted to do. I was like, no, this is it.
This is the way.
You got to come to Google. And this is happening all over the place. Everybody was referring their friends to Google. Once you get in there, you're referring your friends. How did we meet Ben? Spencer and Ben started on the same day at Google.
Oh, that's fun.
They became partners. Yeah, they became partners working on the same project.
Now, I
And
should know this. So you were in it 2002, but Google started when? I mean, this was still very early at Google, right?
yeah, I think they started in 1998, if I'm
Okay,
remembering
so
correctly.
just a couple years.
They were a couple years in, 4 years in. But they were pretty sizable at that point. I think 300 something,
Wow.
400 employees.
Wow.
And they were going like gangbusters already
Oh, I
at
can
that point.
imagine. So I want to go back just a little bit further because I think I've shared this story with you before. I obviously had read about you and joining the company and your history, but when somebody told me that you had founded this graphics program, that like blew my mind because I remember, as I was starting in my career, you get a new PC or whatever, and like, there are 5 applications that you install on that PC. GIMP was one of them. It was like the thing that you installed if you wanted to do image editing. I mean, I'm just curious, what was it about graphics? I mean, when you're a freshman in college and you're like, hey, this is what I want to do with my life. What was it about that aspect or images or graphics that had you, so intrigued? What was it you were thinking or hoping you were going to do with that? Or did you know?
I did not know. I mean, the honest truth is sometimes you start these things and you don't know. I mean, it'd be nice to say it's like, you sketched out the vision, early days of what you wanted this to become. And no, the reality was Spencer and I can't remember what class it was. I think it was an operating systems class. We were taking this operating systems class. We're a little bit bored in it. And we're just like, hey, let's do something on the side for fun. And Linux was up and coming during that time. And so much work had been put into the compiler, the operating system, those basic tools. But the application layer was a little bit Spartan. And, I'd been doing some in high school. I'd worked on the journalism program. I'd had some exposure to Photoshop and Illustrator and some of those other tools. I'm like, hey, let's just do something like Photoshop. And I think I described it in those terms. I'm like, well, we have to start here. And we just kind of started small. And it kind of snowballed. Like you get something working and then you keep on adding things on. And you're like, oh, but I can do this. I can do that. I can add this widget. I can do this kind of graphics effect. I can add this tool. And before you know it, you sit down and you look and like, oh, this thing is actually kind of useful. And open source was early days then. So it wasn't like you just started doing this all in the open. They didn't have Git. They didn't have GitHub. So we would just go on to these Usenet groups and be like, hey, we got this tool. Let's.
Where did you commit code to at that? Because that would have been so long. It was before GitHub. This was before everything, like SourceForge or.
No, it was before SourceForge. I can't remember exactly what we're doing. Like we had a friend who developed his own version control system. PCRE, I think is what it was called.
Yeah, I think that kind of rings a bell.
Yeah. There was some tool back then, and we were just kind of like FTPing back and forth between our personal computers, the source code, and doing code dumps like that. Eventually, like when we initially showed the source code for GIMP, we were just putting it up on FTP. Here's a snapshot of the source code, put it up on FTP, had some build instructions and whatnot.
All I remember is building these laptops or desktops, installing it, and I would use it to edit images for like websites I was building at the time. Had to create some graphics, some banners. Like, where did I do that? I did it in GIMP.
I love these stories.
So funny. Yeah, I know. It's amazing to me. I mean, that was like I said, that was one of the first things that stood out to me when learning about you guys. I thought that was so fascinating.
But we moved on. I never touched it.
Yeah, you guys aren't involved anymore, right?
Not anymore, but I mean, it happened pretty quickly. Left college and just got busy with that day job. Hardly had time for it. And it was just kind of serendipitous timing that there was enough people in the community who were willing to step up and kind of take over ownership of it. I think something different would happen nowadays. Nowadays, if like 2 guys in college, made such a great program, you could probably get VC funding right away.
Yeah.
Probably have VCs knocking down your door and
probably
gone down a different path.
So one of the other things I want to talk about, just related to your history, because this comes up a lot, as a Cockroach employee myself, when we're out talking to people in the field, people always say, "Oh yeah, you guys are open source Spanner," or you're built on top of Spanner, or the other thing we hear a lot. I mean, there's always some Spanner angle, right? Or it's your founders built Spanner. Which you and I know isn't true, but there is some inspiration there. And so I thought maybe it would be good just, for the audience to kind of clarify, not only what tool, I mean, you mentioned it already, but, kind of what you were working on at Google. And then, how did Spanner, if at all, influence kind of some of the early thinking around CockroachDB?
Yeah, definitely some confusion over this. I never touched a line of code in Spanner. So I worked on this system at Google called Colossus. And inside, Google has this distributed file system. They had a version 1 of this called GFS, the Google File System. There's a famous paper about that. And there's a version 2 called Colossus. And I think Colossus is still in existence. It's just continued to be extended. For the audience, I left Google back in 2011. So my up-to-date knowledge about what they're doing is, my knowledge is no longer relevant, no longer up to date. But Colossus is this kind of foundational component for a lot of the infrastructure they have inside Google. And one of the systems that built on top of Colossus, Bigtable. So Bigtable is this, it's essentially HBase is the open source version of Bigtable. It's a, horizontally scalable key value store, columnar key value store, not transactional, doesn't have transactions, didn't have SQL. When Bigtable came out inside Google, a lot of applications started to try to build on top of it. And they were semi-successful. It allowed you to get web scale applications, but there's a lot of frictions with that programming model. And you saw the applications team running into these frictions and trying to work around with the application layer. And some of these workarounds were pretty significant. There was this other tool built on top of Bigtable called Megastore that added transactions and secondary indexes. And at some point, the designers of Bigtable were like, wait a minute, this isn't good. We should actually just put all this into the database itself. And that's where Spanner started. So I was there when Spanner was getting started. Bigtable and Colossus are essentially sister teams, right? Bigtable worked on top of Colossus. We were working closely with the Bigtable team. I did contribute some code to Bigtable at some point because there's this whole transition from GFS to Colossus, and I helped smooth that transition with some changes in Bigtable. The Spanner team was completely separate, something that was, team members from Bigtable moved over to Spanner. I never interacted or dealt anything with the Spanner code itself, but I saw the reason it was coming to existence. It was trying to make the application development easier. And we noted that. Then we saw the continued refinements of that, putting a SQL interface on top of Spanner so it could be used by the ad serving system. And that was really part of the motivation where we had started with Cockroach. Is it wasn't just to do some, transactionally consistent key value store, but is really to acknowledge that you want to be doing this in the database where there's database expertise and not doing it at the application level. When people are putting all this database logic into applications, they usually do it in a way that is fragile. It's custom to what the application needs. And it often works, and then it's not maintainable long-term. Customers, and I've seen this myself, some genius goes in and puts transactions on top of non-transactional database, and no one can maintain it in the future. It does something similar for indexes. So we knew we took a lot of lessons from that. And then also the Spanner paper came out, and that was actually part of the reason that we were able to get Cockroach Labs up and running is VCs are actually just looking at the research papers that come out of Google and then looking to fund companies based on those. So that's a pro tip for the audience members who are looking to found a company, just based it on some academic paper that came out of Google.
So the other interesting question that comes up a lot, when we're in the field, as you know, I work a lot of events, and, people come up to me, they see the banner behind us and they say, what in God's name is CockroachDB? What is this name? How did you come up with this name? So, I know the superficial answer to that, but I wonder if there's a deeper story here about how y'all came up with this name CockroachDB to describe this new database.
Yeah, well, clearly, we named the GIMP, we named Cockroach. We're really good with names.
Penchant for naming things. Yes,
penchant
clearly.
For naming things. I will take credit. I came up with the name GIMP.
Did you really?
Yeah.
All right.
Yeah. So, just kicking around names, you're building something up. Well, we got to name this thing. It's kind of important to give things a name so you can talk about it. And something that's a little bit I think you sense our humor there, a little bit edgy.
Yep.
Spencer was the one who came up with the name Cockroach. I think we were sitting around his dining room table, just kind of sketching out the idea for this thing. We want it to be scalable. We want to be indestructible. And I don't know where it came from exactly, but he's like, we got to call it this thing Cockroach. Those things are going to survive the next nuclear holocaust, and we want this thing to be indestructible and unkillable. So CockroachDB, and then as soon as he said it, it just kind of it stuck. We kind of started spreading the name, and the initial reactions were mixed, but pretty universally, you don't forget the name as
Oh,
soon as
for
you hear it.
sure. I'm curious.
We love that aspect.
I mean, I know out in the field when we're talking with customers, oftentimes it's, when we explain the reasons why, which you kind of did, people's eyes light up and they totally get it. We have had a couple instances where people simply don't want to deal with the name, that it freaks them out or they want us to change the name on paperwork or something like that. But I'm curious, like when you guys first started to kind of take this around to VCs, to kind of some early prospects or whomever investors, what was the reaction? Were people kind of, ugh, or was it immediate? Hey, this is great. I'm just curious. I've never heard a description of what some of that early reaction was.
Yeah, I mean, I was super surprised. Spencer and I did this, initial fundraising round right when Cockroach Labs got formed, and we took a tour of the Bay Area to all these nice VCs, and not a single one blinked an eye at the name. It was just incredible. I kind of thought like we go up there and we'd be, we announce ourselves to the secretary. Hey, we're Peter Mattis and Spencer Kimball from Cockroach Labs. They're just like, okay, nothing. There was nothing at all. So the VCs were just nonplussed by the name. Several of them commented that they really loved it. It was very memorable. We got that. I do remember distinctly though, like maybe a couple months or a year, and we started actually doing tech talks at companies trying to spur some initial interest in CockroachDB. And I remember giving one early days, and afterward an audience member came up to me and he was like, well, this is really interesting what you're doing, but I guarantee you no CIO will ever sign a check to Cockroach Labs, and you just have to change the name. And I was like, okay, no, we're not going to change the name, but okay. And then, fast forward like another 5 years, and, CIOs seem to have gotten over their reluctance. I don't think that guy knew what he was talking about.
Yeah,
if you're out there listening.
Definitely don't think that that guy knew what he was talking about. No, I think we haven't had that problem.
Yeah, but we have heard repeatedly, there is some very strong negative reaction from a very small segment.
I'll say this, having, again, spent a lot of time out in the field, it is so unique and differentiated. And, although people aren't necessarily at first pass always going to understand what we do, once you give the quick explanation, it absolutely and totally resonates. I mean, people get it. It's like their eyes light up. They're like, yes, yeah. I like this.
And then we actually are softening the term over time. I mean, I don't know what your perception is of cockroaches anymore when you hear the term, but I have a generally positive connotation towards that term nowadays. I think that's true of many people at Cockroach Labs and some of our customers too. So, if
there's no shortage.
If you have a fear of cockroaches, you should come work here because we will actually
and of course, because we use it everywhere for everything. Like, no company event or title goes by without somehow making the tie-in. But that's okay. We love them, and it's been great. So just going back to kind of the database itself, it's been now out in the wild for, was it 8 years? I think we just had our 8-year anniversary. We're adding new features, new capabilities all the time. But if memory serves me correctly, the database that you had in the first couple years looks a lot different than it does today. Can you kind of talk a little bit about, what some of those big changes were, or what some of the, the early differences, the differences from the early days to today are? I know, for example, SQL wasn't always a thing. There was some debate about the nature of SQL that you can use. Can you talk a little bit about kind of what were some of the early designs or thoughts about CockroachDB when you first got started?
Yeah. Well, I mean, you're absolutely correct. I think we're known as a distributed SQL database today, and we put a lot of effort behind that. We did not start out that way. With that initial roadshow with investors, we were talking about being a distributed, horizontally scalable, transactional KV database. And we thought we were going to provide a KV interface to users. And we were, I think it was 6 months, 9 months into the lifetime of the company, trying to figure out exactly what this KV interface, we had initial prototypes for what it looked like, figure out what that KV interface would look like. And, as we're looking at this more and more, we're just like, wow, we want to make this thing rich and powerful. Doing something new there has a lot of overhead to get people to adopt it. And we decided to go with SQL. And we made kind of a 2-step decision there. We decided to go with SQL, and then we're trying to figure out what dialect of SQL do we want to do. And we decided to go for Postgres, just things thinking, the thought process being they're a little bit more adherent to the SQL standard than MySQL. And that was momentous. As soon as we made that decision, we took on a huge chunk of additional work. But we're taking a huge burden off application developers. And that was just right in line. Our investors were super excited about this. Early customers were, though they were also like, how are you going to do all this stuff? They didn't see the path where we were to where we are today, which is it's a very significant path. You have to build up, this kind of SQL execution engine. We had to add a SQL optimizer. It implied a lot of things. And, there's significant challenges we had to overcome. That was like the biggest, most momentous decision that we changed path on. There's just a ton of other stuff that it has evolved over time. Our backup restore system, the addition of change data capture. Change data capture, we were getting started. That wasn't on our radar, but it's clearly super important. And then of late, one of the big things that's really evolved over the past couple of years is just the importance of migrations, making it easy to get existing applications onto CockroachDB. And this comes in a whole bunch of different flavors. We've done work on Postgres compatibility for a long time. That's a huge impact on migrations, support for drivers and ORMs and other development tooling that programmers like to use. But it's deeper than that. It's like, does the application have to change at all? And for some things, there's certain fundamental things that make, you kind of need to change it when you're moving from a legacy single node database to a distributed one. I'll give you one example of this. If you are using sequences, the sequence type, that's like the single hotspot. And any distributed database is going to struggle with that. You're going to have a limitation on how far it can scale it. And if you can replace it with something like a UUID, you're going to be able to get much higher throughput out of your distributed database. But that's one example of something that feels a little bit fundamental. And yet even that one, we're still working to make it better. Now we have hash sharded indexes so that we can, try to, spread across that right hotspot. But everything I think we're doing that we've done to date, we had this original mission when we formed Cockroach Labs. And I really love that mission statement. It's like very broad, very ambitious. It's just make data easy. We want to make data easy for our users. And we moved away from that mission. I still love it as just super simple and also a guiding principle.
Oh, I think it's amazing. And I wonder too, when you guys first started out, obviously, the product has grown in complexity. Did you have a sense of how, I don't want to make it sound negative, but all the things, because you just, listed a lot of stuff and there's even more to the product, obviously. Did you have a sense of how rich this product or feature set was going to need to be in order to compete in the space, when you first started out? Because, to compete against some of the largest companies in the world who are building database products, you need to have, just this very wide ranging set of features. Was that part of kind of the early thinking, like, hey, we're going to start here, but we've got this mile long list of features? Or did you ever really think that far out? I'm just always so curious about people's mindset when they get started, because you're 8 years into it now.
Yeah, no, I think that's a great question. And honestly, no, we did not. And I think that's something that is a useful attribute in a successful founder, that you have to be smart enough, bold enough to be able to set something in motion, get the foundation in place, but not so smart that you see exactly how much work it's going to be. If you're like standing at the base of the mountain and you look up and you actually can see to the peak and see how high Everest is, no one would ever climb it. But you just start, putting one foot in front of the other. There's this phrase I like, mountains beyond mountains. I feel that that's the startup journey. You can kind of see the mountain in front of you and it's intimidating, but you can see a path to the top of it. And you get to the top of that mountain, you realize there's another mountain beyond it. And you just go like, okay, I can see what I need to do. I'm going to start walking down that and, accomplish that. And there's another mountain beyond that. Right. So, we've got to this point now, we built, we've summited many of these mountains, we have this distributed, horizontally scalable SQL database. It actually works for mission critical workloads out there in the world. And yet there's additional stuff, the migration stuff I was just touching on. That is a mountain we're going to be climbing for years. There's just so much work to do there to make it seamless and easy. And, not just have enable the migration, but doing it with zero downtime, for example, live migrations. And that's the thing that keeps me going still, is I just keep on seeing the next mountain and being like, I see a way to accomplish that.
Do you think we'll ever be done?
No, I
I
don't
don't
think
think
it'll ever
so
be
either.
done.
I
No.
don't
At
think
least
so.
Cockroach, Tim and Peter might be done at some point, but Cockroach Labs will never be done.
Always a long backlog of features for sure.
Yeah. And for, like I kind of saw some of what was going to be needed for, the fundamental capabilities of a distributed database. The thing that I had no visibility to is just the amazing amount of integration you have to do with the enterprise ecosystem. And this comes up all over the place. Security is a huge thing, how much security encompasses, the compliance standards you need to adhere to, observability integrations, the ORM integrations. I didn't realize how long that tail of functionality was going to be.
No, I agree with you. And of course, as you know, I mean, we're on the front lines of it and hear about, a new thing every day that people want to do or use with Cockroach. But I think, we're solving a fundamentally important problem that has been, I think, traditionally very difficult for other companies to solve. And I read an interesting article, and I'm curious about your perspective on this. This idea that Moore's law is dead, that CPU power is kind of flatlining, if you will, it's not doubling every year. And the argument that was being made there is that, whereas traditional databases, you could easily kind of swap out your main database node or server with a CPU that was much, much faster to kind of continue to eke out performance. You simply can't do that anymore. And um, to really keep up ultimately with modern workloads and modern expectations, you need to be able to scale horizontally your database. You can't just any longer rely on Moore's law to get you additional performance from the same old box. And so I think, what's interesting about where we are as a company right now and what we're doing is that I feel like all these market forces are moving in our direction. Distributed databases are absolutely a thing that people need. Being able to run across cloud providers turns out to be a really, really powerful tool. SQL as a language turns out to be incredibly popular and powerful right now. And it seems like all of these things that, I think you and Peter or Ben and Spencer kind of thought, oh, this might be a good idea, 8 years ago, turn out to be like, I think, right at the heart of where people need to go right now. Um, I'm just curious on your thought of like the timing of it all.
Yeah, better to be lucky than good, I guess, is maybe something I think about. I mean, I think some of this was we had foresight into. Certainly, our experiences at Google give us, some foresight that horizontal scalability was extraordinarily important, and that there are limits to the vertical scaling you can see of a single machine. This is Moore's law on the CPU. This is the amount of RAM you can pump into them, amount of disk you can put onto them. And then there's also just kind of fundamental reliability aspects if you put that much hardware into a single machine. So we saw the horizontal scalability was going to be extremely important. Yeah, the SQL stuff is maybe a little bit surprising to me. I didn't know how much life SQL would have. But, when we started looking at that, and I was on the forefront of looking at like SQL versus alternatives, it was very clear. It's like, Cassandra was big, HBase had some traction, but SQL dwarfed it all by like 2 orders of magnitude. And so there was like definitely foresight. It's like, this thing is there. It's not going away. It's being enhanced and people are extending it. And it's like, it's only continued to be that way. Like, I think, at the time that we were starting Cockroach Labs, NoSQL was still like a hot thing, but we were actually on the tail end of that. NoSQL isn't going to go away, but SQL was resurgent at that
I'm
point.
very curious about that because it's interesting, when you guys were kind of meeting with those early investors, I think you're right. I mean, NoSQL was very much the thing. Was there any concern at the time that, this was going to be too crowded of a market? I mean, I'm trying to remember what else would have been out there at the time that was like pure NoSQL, but certainly
Yeah.
for me now, SQL is such a big differentiator, but then you guys didn't have it. What were the kind of hallmarks of the differentiation back then, if you can recall?
Yeah, I mean, some of our early investors, they were familiar with the Hadoop ecosystem. They saw how it had grown. They saw how it also was running into its limitations. Cassandra was out at that time. React was also out at that time. The differentiators we were originally going into, though, is basically like our pitch, to some extent was, hey, we're going to be the open source spanner. You saw like how, Bigtable and GFS and MapReduce had spawned the Hadoop ecosystem. Well, Spanner is also going to spawn it. And the thesis was pretty easy for investors to wrap their heads around, that you want to have this and by the way, Spanner at the time was also a KB system. It added SQL
It's-
later on. So they were just looking at that,
okay, I
you
guess
know,
I didn't realize that. I thought they were always SQL.
yeah, no. They actually, the SQL got added in later, but the cloud spanner has always been SQL, has always had SQL, but the internal version just had a KB version. And then there's like a separate application team for the AdWords actually put SQL on top, and then they blended it back in over time. But it was really like, our initial pitch was like, hey, we don't want to burden application developers. NoSQL puts a burden on them. You lose transactions, you use indexes, you lose this rich query language. Well, we want to, put back in transactions and indexes. We feel that these are things that it's database engineers are best suited for implementing.
One other thing I wanted to touch on, well, we may want to touch on many things, but the other kind of big, I think, monumental change, at least from my perspective, you may disagree. I mean, certainly introducing SQL was a big change, I think, in the direction of the history of Cockroach. But what many people also, I think, have heard about at times is that, oh, there's something to do with RocksDB. RocksDB is this underpinning of Cockroach. At some point over the last couple of years, we made a move away from that to something we call Pebble. And I know you were very, very much involved in that decision and engineering process. Can you kind of walk us through, a little bit of the history of RocksDB, and how and why Cockroach was using it, and then what happened when we decided, or what initiated the thinking behind moving beyond that?
Yeah. So RocksDB is this low-level key-value storage engine. What I mean by low-level, it's really for a single machine. This is how CockroachDB initially was storing data on disk, is using RocksDB. RocksDB doesn't have transactions, but it has atomicity and consistency and durability guarantees. And so we were building CockroachDB on top of this. And to be clear, it's not that CockroachDB is just it's a RocksDB with a little, like a small bit of glue. It was actually the glue is very significant, but RocksDB was an incredibly important component of that. And RocksDB is fast. It comes from Facebook. Its pedigree is actually there's an open source software from Google called LevelDB. The RocksDB folks took it, forked it, and made RocksDB, and then added a whole bunch of optimizations and enhancements for functionality. So we were relatively happy with RocksDB. When you're building a system as complex as CockroachDB, you don't necessarily want to build everything from scratch. And RocksDB was one of the big components we were deciding to use. Another big component, we decided to use gRPC for communication between nodes. And, there's several other big pieces of open source software that we were built on top of. There was a little bit of an impedance mismatch with RocksDB, though, because CockroachDB is written in Go. We like that choice, some grumbles on the edges with garbage collection, but we're generally very happy about that choice. RocksDB is written in C++. And in order to bridge the two, you have to use this functionality from Go called cgo. And this implies some fundamental overhead in doing certain calls. And we mostly worked around them, but it was a bit of a headache. And so our interface between the main CockroachDB code and RocksDB was fairly narrow and very tailored to be heavily optimized, but that made it somewhat inflexible. And we looked at some point, we didn't have expertise for maintaining RocksDB, knowing the C++ code, and we could have built that up over time. But there's, we had to have engineers transitioning between Go and C++. And at some point, we're like, no, actually, we think we can do this ourselves better. And essentially, you can look at Pebbles, almost a fork of RocksDB. Essentially it was RocksDB stripped of all the things that we didn't use at CockroachDB and re-implemented in Go. And it was great to see that we could actually get something as performant or actually faster for CockroachDB written in Go. It removed all this kind of that impedance mismatch I'm talking about, the transition between Go and C++. And then since doing that, we've been able to keep on extending it with functionality that is very much tailored to CockroachDB that wouldn't necessarily be useful to try to upstream back into RocksDB.
Yeah, I think it's been a huge win for us all around. And of course, it shows, again, the Cockroach Labs team penchant for naming things, RocksDB, but want a smaller, more compliant version of a rock, which
is exactly where the name came from.
We love this stuff. You
Yeah.
touched on another interesting topic I kind of wanted to get your perspective on. So, this kind of lineage between RocksDB and Pebble, obviously borrowing or using some of this code initially. We're a Postgres compatible database, but oftentimes in the field, or just maybe a casual observer will hear Postgres and think we are a fork of Postgres. That we've done something to the Postgres binary and added some features to it. Can you talk a little bit about that and some of the reasons why we didn't go down that road? Perhaps I'm just curious.
Yeah.
Your thoughts on this topic.
Yeah. No, we are not a fork of Postgres. We do not take any code from Postgres. I think there might have been a couple of occasions where we tried to reverse engineer precise semantics of Postgres. But we've done that very light code spelunking, not anything where we've actually taken and forked code. Part of the reason for doing this, the underlying storage engine, the capabilities of our KV are fairly different than what Postgres are. And trying to map the Postgres code onto that, it was kind of felt more difficult than doing it. There's another aspect to it too. We weren't committed when we initially did SQL to being fully Postgres compatible. And that was actually something that if I could go back and do it again, I would have just made the mandate initially. We were just going to be perfectly Postgres SQL compatible. We said like for the SQL we implement, we want to be compatible with Postgres, but not necessarily doing the full kit and caboodle. And that was one of the lessons, it's like, I really loved having made that decision to adopt SQL. I really loved adopting PostgreSQL as our dialect. Just should have made that decision right up front. Just be fully compatible. It would have removed a lot of headaches we had later on with regards to compatibility. That we're nearly at the tail end of this now. I look at this every now and then. We kept on chipping away at our compatibility. We're nearly done with it, and we've been to a sufficient level for years, but I think we could have gotten there a lot faster if we just upfront said, no, this is the goal we're shooting towards.
Are there, you kind of touched on another interesting topic, which you and I've talked a little bit about before. I mean, these kind of idea of lessons learned. So that's a great lesson learned, I think, when you look back at the 8 years of history with Cockroach. Are there other things that jump out to you like, geez, I wish I had known then what I know now? It doesn't necessarily have to be technical. Maybe it's just about, leading an organization or all sorts of other stuff. I mean, you've had such an interesting role in the evolution of the company and the product. I mean, any other thoughts come to mind about, lessons learned?
Yeah. One of the ones that strikes me, I always think about this nowadays because we're still dealing with it a little bit. We've added a lot of multi-tenancy features to Cockroach of late. And one of the things that, like this has enabled us is a very clean separation between user data and system data. And I wish we would have made that separation much more clear up front. Part of the multi-tenancy is great because it's enabling serverless functionality. We've had to retrofit this onto the system in order to get multi-tenancy deeply embedded. And it would have been much easier to do it from the get-go. And this separation between user data and system data, which isn't quite tied to multi-tenancy, that is kind of a separate thing, but it's just the realization. User data from the perspective of an operator, as we're operating CockroachDB in the cloud, is kind of quote unquote toxic. You don't want anybody inside Cockroach Labs to see this. And we've had to go through and ensure that we're redacting any mention of user data from operator views, but to leave the system still operable, observable, debuggable while redacting all that user data. It's taken quite a bit of effort. And it's just one of those things, if you had known upfront about this and known this is a core principle that you need to be adhering to, it would have just been a lot easier. I think the other thing that we had some early feedback on, and I kind of think that our call here was right, was just about should we be adopting the cloud or being and perhaps even cloud only. I think if we were starting today, we would have to fight a lot harder to make it so that CockroachDB was available self-hosted. I'm happy that CockroachDB is self-hosted, but that the world has moved on. It's kind of clear that you can build cloud-only software as a service companies. Snowflake is a primary example of this. completely eschewing the self-hosted route just to focus on the cloud. We didn't get that, and I think it was the right decision. But I look back on it, it's like a couple years difference, and we probably would have made a different decision.
Well, but we are doing some interesting things in the cloud, I think, and you mentioned it, but I'm curious, or would love to kind of get your perspective on not only kind of where the inspiration came from, but to some extent where we think we're going, and that is this concept of serverless. I know serverless can mean lots of different things to lots of different people. Kind of, it's a term that comes with its own set of expectations. But we do have a database that we're calling kind of our serverless product. Can you kind of share with our listeners what this is and maybe how it's different from conventional definitions of serverless or not?
Yeah, I'm not even sure what the conventional definition of serverless is anymore. It means so many things to different people. I mean, when we think about serverless, I really think about like not having to worry about the database servers. There's clearly database servers on the back end. You don't have to worry about them. And this is serverless in the way that S3 is serverless. You're storing data in S3. What servers do you see there as a user? You don't see it. They're just providing guarantees around what the API is going to be, the durability, the response times, and you're not having to worry about the servers whatsoever. And we think this is core for database users as well. I mean, I think there's some, database users, that haven't kind of caught on to this. They're thinking like, no, I need to worry about like, I have servers, I have them at this location, but really that provisioning headache of like what servers in particular, how do you add new ones in response to changes in load or workload or whatnot? That's a painful, painful thing to be doing it. And I have a dream. I have a dream that at some point in the future, application developers never have to worry about their database servers. They're just worrying about, I have this database API in the cloud. It's SQL. I can set guardrails on how much I'm going to spend on this, and it will scale with me. It'll scale with me to the geographic locations I need. It'll scale horizontally within those geographic locations. You just completely get rid of that concern about servers. The other aspect of serverless for us, though, is we want to scale down to incredibly small sizes. So the implementation here is kind of interesting to understand. There's still servers underneath. There's always going to be servers, but you just get a virtual slice, and you don't have to worry that, I need like these physical servers in this physical location. No, and because it's a virtual slice, it can scale down so that, if you're not using it at all, you pay close to zero. Depends on how much data you're storing. We might charge you some, but it's close to zero. And it elastically scales up very responsively under demand, which is also an incredibly important aspect. This isn't serverless per se, but this is what serverless enables is, you should get charged for what you're using. And that means, adjusting to load during the day. So many applications have peaks of load, during lunchtime or dinner time, or, when a news story comes out, and elastically scaling up to meet that node and then scaling down when it's not being used anymore can make your system a lot more cost effective.
Yeah, I think it's some really powerful concepts. And I think, and correct me if I'm wrong, but kind of the underpinning of this, or at least part of it, is this ability of Cockroach now to really separate kind of compute from storage. And by compute, I mean SQL. So, you kind of have this idea in the serverless, deployment model of kind of SQL nodes, which are distinct and separate from the underlying storage nodes. And that's kind of one of the things that, you don't really have with our more traditional offerings that you do have with serverless, is these things become different, can be scaled independently. And ultimately those SQL nodes can kind of go down to near zero, but your storage remains. And then, the ability to spin back up SQLs is kind of a neat and interesting thing.
Yeah, well, you absolutely nailed it there. I have nothing to add.
Great. Perfect. So I know we're kind of running up on time, and I don't want to hold you more than the time allotted. As you well know, it's spring, right? The flowers are blooming, but it's also kind of the beginning of the Cockroach Labs fiscal year, which it's always a time, at least for me, to kind of reflect or think about kind of some of the things that are coming in the near future or the year ahead. They're just curious, like, what are some things that you're excited about, as we kind of start a new year, new fiscal year? What has you excited? I mean, you're going into your 8th, 9th year at Cockroach Labs. What's going to make this year kind of the best year in the history of the company?
I like it. Every year is the best year in the history of the company. Yeah. Well, we're still here and we're kicking. Yeah. I'm excited. The multi-tenancy stuff that we built with serverless, I think we're going to start seeing, that penetrate, into other areas. We're seeing companies experiment with this on their own with CockroachDB, on self-hosted, and they're doing it themselves. And we're we're like, no, wait a minute, like you guys can actually start using this functionality we built right in there. We built in a lot of isolation facilities there directly into CockroachDB. Those are all coming to fruition and being, spread throughout so that applications running on the same database, they don't interfere with each other. Background operations don't interfere with foreground operations, and much steadier, latency guarantees so that, like when something goes awry, things go awry. This isn't necessarily the database itself. Sometimes it's the application. I mean, we've heard multiple times of application getting rolled out, oops, forgot to add an index. This is doing a full table scan. And, be able to quickly observe that. Our observability tools have gotten better. There's still ways to go, and we have things coming up that are impactful there. Kind of a little bit longer term there too. I mean, what we can be doing on workload recommendations, telling you when you have a missing index, you have unused indexes, that stuff is there now. It's going to get more powerful over time, going to make increasingly intelligent suggestions there. And I love that stuff. And then also we're starting to see, like back on the cloud side, the serverless and our dedicated offering there, just increasing traction with customers. We've built a ton of functionality that enterprises need to be using this stuff. And now I'm super excited to see these enterprises start to use the cloud offering, get all that good CockroachDB goodness in the cloud package.
Well, Peter, it was a pleasure as always to chat with you. Thank you so much for spending a few minutes today and sharing a little bit of the history of you, the Cockroach Labs, CockroachDB, and ultimately where we're headed. So again, thank you so much for joining Big Ideas in App Architecture.
Oh, thanks for having me, Tim. This is great.